So jumping into Jupyter Notebook. So I've got my data set from Kaggle. This is called Nutrition Facts for Starbucks Menu. So I've downloaded the CSV file and loaded it into my notebook using the Pandas and perform some exploration. Uh, I want to run some queries in caffeine, but during exploration, I found some string there as well, which might cause problem when we load it into Hive. So we're performing some cleaning. We're replacing any strings to null values, and we're also changing these from strings by removing this percent sign into numeric values. This is just some visualization, and I've exported it to a new CSV file, which is like this. It has 242 rows and 18 columns. This is the new file. And jumping into our Google cluster. So I've already loaded the data into my cluster. I've loaded the data into my cluster, copied from local to our Hadoop file system, and from Hadoop I've imported it to my Hive table. So this is our table. As you can see, the data is already here. And this is how we are storing our data. The caffeine is in integer. Um, Calories is also in integer. My queries, my analysis mainly focus on these. So our first query is going to be to get average calorie by category. Okay, so we're selecting beverage category and averaging the caffeine, rounding the values to 2 decimal points, up to 2 decimal points, and storing them as average caffeine, and then showing the results grouping by beverage in a descending order. So drinks with highest caffeine, like coffee, it has 293.75 caffeine on average, and blended cream has 0% caffeine, smoothie has 5, uh, 0 caffeine, 5. These are in mg. Now, secondly, we want to know which preparation style um, has the least amount of calorie uh, per 100 mg of caffeine. So calorie to caffeine ratio. So the previous operation took us 12.35 seconds. This one took us 8.1 seconds. So now we can see that our short will have 3 calorie per 100 caffeine. Similarly, and we've gave it in ascending order, so uh, least calories by per 100 caffeine. Now we're in a new cluster, a new shell. So here we'll go into our Spark. So uh, The Starbucks menu CSV file is in our Hadoop file system in the directory Big Data Spark. So we've loaded it to our Starbucks. From there, we'll remove the header row. So the first row starts with beverage category. We're searching for anything that starts with this string and then removing it. Now this is in our memory. So both operations, we can do it with this. Uh, so here we've load the data, our Starbucks CSV into Spark, and then we've removed the first row that has the header values. And then we're splitting the data into columns, splitting by every comma, and then mapping each row to a tuple. And then we're mapping each value of caffeine, and then we're performing aggregation to the caffeine value. And here we're just calculating the average. So total caffeine that we calculated here divided by the total count of the beverage. And here we're and getting it in ascending falls, so descending order. So highest value will be at the top, and then it will go down. So and here we're printing our result. So we can see this is our result. If we look at the Hive command, so select beverage category and rounding it. So here I've not rounded it, but we can see that coffee 293.75, and then classic espresso drinks has 122.06. It has 122.07. So similarly, we have we got the same result, but the process to get the result uh, is vastly different. And now we'll do the same for calorie to caffeine ratio. So yeah, again, we can use the same data as. So now we're doing the same for caffeine to calorie ratio. We can use the same data that we had because since it's already loaded into our memory. Now we're mapping preparation style. Now we're aggregating uh, the calories and caffeine uh, for the preparation style. Now we'll calculate the ratio. And we're getting the result. So here we can see we have the same results. So short has the best caffeine concentration with least amount of calories, and everything else is the same. So this is the amount of code we had to write for the same query we could do in Hive like this.